So we will try to get through these questions as quickly as we can. Okay, this is a trick I learned some years ago. This goes 3, 2, 1. I don't have to do it. Shh. Great, great. Thank you all very, very, very much. I have 2 quick announcements. The first one is relatively important. It kind of depends on what you think of your kids, but don't forget to pick up your kids for lunch. If you've ever done that, raise your hand. No, don't. And secondly, many, if not all, of these presentations, everything that's being live streamed will be available on our website, and the presentations will be available on our website. If the doctors haven't released them yet, we'll strong arm them to make sure that they're available for you to see on the website as well. So with that, we're going to get underway with a series of questions, and I'm going to direct this first question to Dr. Pachman, and the question is, how likely is it that someone who has active JDM as a child, young adult, will have a relapse within their disease after years, maybe decades of remission?
My grandmother taught me to say, I wish I knew. First of all, I'm a pediatric, so I would not see the children when they were older. But what we can do is we could canvass my 600 kids and see if they've ever had relapses. We haven't done that yet. What you heard today was marvelous, and it's a fraction of the things that need to be done. And as you gather, we're still doing them. So I don't know. I can't tell you. If we knew more about the circumstances of why the disease started, then I could tell you that at a later time, it won't come back again.
Dr. Ryder?
Okay. Well, I have seen some of the adult patients grow up, children grow up to be adults. I think my experience is also anecdotal. I think, like Dr. Pachman, I don't know either. And I agree we need more research about that to figure that out. I would say that some people I see are doing quite well. I'm happy to see one of them here, in fact, at this conference that I saw more than 10 years ago, and is grown up and in college and doing quite well. And others I see somehow the disease has been quiet a number of years, and it does seem to come back. And sometimes I see factors that we thought were triggering the disease at the beginning, like a sunburn or a bad infection or a really stressful time in their life, that seem to have flared things up again. And I can't predict, though, when that would happen or if it would happen to everyone.
Great. Next question. A number of families do their IVIG treatments at home by a home health nurse. Why don't more doctors or families do this? Our experience is that it is less disruptive for the family, reduces exposure to having to go to an infusion center or hospital, and the healthcare costs are significantly less. Dr. Kim, would you like to take a pass at that one?
Okay. Oh, sorry. I think that we are increasingly using IVIG home infusions, but it's taken a while for, I think, pediatric rheumatologists to trust that these infusion centers can do a good job with our patients who often need IVs repeatedly and often are hard sticks and hard to get IVs into as well. I've definitely had patients who we've tried to do home infusions on who change their mind and want to come back to hospital-based infusions because the expertise of the pediatric nurses who do those things is so much higher. But then I also have a subset of patients that do great with home infusions. There's another benefit to having infusions done at the hospital. which is having the physicians being able to see the patients in person there when they come in for their infusions. So it helps me when my patients come in for infusions to see them on a regular basis, and also have labs done at the same lab, processed in the same ways, to monitor them closely through time. So we try to do a balance. So in patients who can make trips out to the hospital on regular basis, we do try to have them come to the hospital to do those things for the reasons I stated. But certainly patients who come from far distances, and now I live in California and the state is very, very big, even though it's one state, that we do have to do some home infusions, and it's a balancing act to try to figure out what the best is for each individual patient.
Can I add to that? Is that all right?
Yes.
Of course.
Thanks. So I agree that there's a lot of benefits for doing it in and out. Sometimes at the initial visits, you really want them done at the hospital setting or in an infusion center setting and not in home, because you're sometimes worried about side effects, and you want to make sure you are noticing if a child or an individual is tolerating it. The other thing I just want to mention, in addition, is that there's many insurance agencies now mandating that infusions like this are not done in a hospital setting, and that's because of cost. And it's not 100%, but there are many areas and states where now, like Blue Cross has just mandated certain things in the state of North Carolina, and I know other insurances have done it elsewhere, that you're going to have to get it done elsewhere. And so it's not a bad thing to get it done at home and have a home infusion. It can work quite fine. It just depends upon all those other logistics sometimes.
Dr. Reed, hold that microphone. The next question is also for you. And related, if trying to taper, reduce IVIG, is it better to decrease dosage or frequency? And can anything be done to reduce fatigue?
Fatigue from the IVIG? Is that what the question
I'm
says?
not sure what the intention was, but I think perhaps fatigue in general.
Okay.
We do have some presentations on that. Go, please.
So I don't think we don't have data to suggest one way or another is better for decreasing IVIG. Most individuals will decrease the frequency of it first before they decrease the dose. The exceptions are if you're on a 2 gram per kilo dose and people are having side effects when they get it, sometimes they'll go down to a lower dose and then try to spread them out over time. That's probably more commonly done and more commonly tolerated. As for fatigue, that's a great question in terms of how to improve fatigue. I do know, I've heard both people tell me they get a lot of fatigue after they've had their infusions, and so we're not quite sure how much is from the infusion, or sometimes we do medications around the infusion to try to prevent side effects. How much of that is related to that? And then I know patients who tell me they swear that once they get their infusion, they have so much more energy. So it's really depends, and it's very individual.
Question, please.
Say a little more. I want to say that with IVIG, that the half-life is 30 days. So my experience is that with many patients, that if we try to space it out, that they don't tolerate that as well if they still need the treatment. And we even have people who break through in the month's time, and some people need the treatment really every 3 weeks or even every 2 weeks, is my experience. So I find it actually my own experience, and it's all anecdotal. I think Dr. Reed is right. We don't have the data, but I find it easier to take down the dose rather than space out the frequency as we're tapering it down. In terms of fatigue, I think that it's very multifactorial. It's an area we need a lot more study. It's obviously very important to all of you and your children in terms of their ability to go to school and do all the things they want to be doing. And there are many different components to it. One is the active disease, and one of the real stories we get is that as people's muscles are inflamed or that they're damaged, that they get tired later in the day after using their muscles a lot. Other people are tired, as Dr. Reed said, because they need another infusion. The medication isn't holding them, and they derive a lot of energy after the treatments. Other people are tired because there are other things in their life that are making them feel tired. Stress and depression and anxiety and other things that can make people feel tired, and they tend not to feel rested when they wake up in the morning even. Sometimes people have more than one of these things going on at once. And sometimes exercise itself can be beneficial for a number of these different things, but sometimes even at first, the exercise can make you feel more tired.
Question for Dr. Cow. How or what is the genetic effect on offspring having JDM?
Oh, what's the rate of offspring?
Well, the question is, how or what, if any, is the genetic effect on offspring having JDM?
Well, I don't think, one thing we're trying to find out is what the genetic factors are that influence development of JDM. We don't really know what all the factors are. There's some of the strongest signals coming from MHC, and if you have a particular MHC haplotype, you're definitely more likely to develop JDM, as particular certain types of JDM. But to actually get a risk score or inheritance score, that's one of the things we just don't have enough, I think, samples yet to then be able to do that. Because even though cases with where you have the registry and so forth, I don't think there's been studies done to look at the families as well to then develop a genetic risk score yet. I think we've done that for other autoimmune diseases that are published on. And for every autoimmune disease, it can be quite different. It can be anywhere. The genetic contribution for something like inflammatory bowel disease is actually around, I think, around 50% or so. And it can only go anywhere from 20% for some autoimmunes up to maybe even 70, 80%. So actually the study for JDM hasn't been done yet. And that is one of the things that we're aiming towards. And part of the complication is because it's a multifactorial genetic disease. So it's not as simple as, for example, cystic fibrosis, where one gene, one mutation will then lead to the disease. It's most likely for each individual person, it's a very private mutation that contributes to it. And also in other cases, it could be multiple genetic hits that can contribute to it. And on top of that, it's not fully penetrant, that even family members who might share the same risk, the exposure to the environmental stimuli won't be the same, so that they may not actually penetrate and develop disease, even though they have the same risk factors. Just like with other common factors, like even, for example, cancer susceptibility, there are genes that make you more susceptible to get cancer, but whether you actually manifest it throughout your lifetime is not 100%. So the short answer is that now we have registries like the CARA registry, and hopefully the registry collect more from patients from the CureJM families once we have the numbers, and we also have information from both the family as well as not, that's also important, is to have the family information and their genetics on top of just the affected kids. We can then start doing more of these type of genetic risk score and prediction type of studies.
Dr. Pachman.
I'd like to tell you that over the 600 kids in our registry, which preceded now the national registry, no parent had myositis. And so that I can tell you, what the most frequent autoimmune disease that was in the family was that one of the parents, often the mother, had lupus. And we published that. So as JDM is part of this family of autoimmune diseases, why does one person develop one autoimmune disease and another with a similar background develop? And this is really what we need to understand. But I don't think you need to, we have one family of the 600 where there was more than one child with JDM. So I don't think you need, that's not high on my worry list.
Question to be shared between Dr. Nagaraju and Dr. Kinder. Why start with normal myoblasts rather than using cell lines that are already from JM patients?
So for the case of the assays I'm working on, I think one of the crucial features of this high throughput screening is that we need enough cells. And so if you take myoblasts from any muscle, they only grow for so long outside of the body, so we can't expand them large enough to do the high throughput screening. So we need to use genetically immortalized cell lines, and there currently do not exist immortalized myositis myoblasts. So that material just doesn't exist. I've been talking to the group in France who immortalized the normal cells, and they've immortalized other muscular dystrophy cells. I'm uncertain at this point if they're going to do myositis immortalization or if they'll do it and use them themselves. But that's something I would like to do. And I think, as I had mentioned in my kind of like pipeline of our development process, I think we would use normal or non-immortalized patient cells kind of as a confirmatory step nearing the end of the process. So we can kind of do a first pass large screen with normal cells, and then ultimately test them if we get hit compounds or hit drugs, test them in patient cells in smaller scale experiments.
Yeah, just to expand on what Travis said, if we take myoblast muscle cells from a normal person and then we culture them in the lab, you can multiply them probably 8 times. That means what we call 8 doublings. But if you take the same thing from patients, not only JDM, even other muscle diseases, they hardly grow probably couple of passages. That means couple of the doublings. So we will not be able to use, because they multiply so less, because Dr. Kinder's assay requires millions of cells. So that is why we have to first go with the normal and mimic the disease in the normal. It's because they grow. And then confirm that what we mimicked is actually really seen when we take patient. Because and also patient biopsies and cells are precious. They are very few and they don't grow. These are all the complications.
There's a question for, let's see, Dr. Pachman, please. Our daughter is 9 months into treatment and has improved significantly. Her biggest complaint remains muscle burning and pain. When can we expect that to go away, if ever? And is it indicative of disease activity?
It's a really good question. But unfortunately, a lot of what medicine is actually seeing the patient. And I can't answer a question like that without examining and talking to the patient. So, because it's like baking, it's how a patient feels and what you learn from the family. So, if a muscle is burning, then I need to know, is it burning at rest? Is it burning with activity? Does sleep help? There are a lot of things that would need to know about that. But I can assure you that the symptoms, when properly treated, when the right combination is found for that particular child, then the symptoms go away. And when I teach, I love to show a picture of one of our children that came in as a Z and is now a ballerina.
For Dr. Reed, do we have statistical evidence of increased likelihood of scoliosis in JN patients?
I don't know of any data that suggests that you have scoliosis related to myositis, dermatomyositis. There are some dystrophies and other forms of muscle disease that do get scoliosis, but not inflammatory muscle disease.
For Dr. Kim, how do we know when it is time to start weaning off medication to see if the child is in remission? What does remission, quote, look like initially?
These are all hard questions you guys are giving us, yeah. So as Dr. Pachman said, it's very individualized for each patient. But in practice, I think a lot of our approaches is looking for really normalized or moving towards normalized muscle strength and completely normalized muscle enzymes or blood testing before we think that patients are doing well enough to start going down on medicines. And if that isn't achieved, I think it's important in practice for pediatric rheumatologists to think about adding other medicines to get the disease under control so you can decrease steroids and steroid side effects. I think there was another part of the question that maybe I'm not answering.
Now I have to go back and
No,
find
no.
it.
Do you guys have anything else to add?
Does anyone have anything else to add to that? Okay, question for Dr. Nagaraju. How do I know what my child's biomarker means?
Yes, yeah, thank you. So the biomarker, the term is used quite extensively. So often there are also different terms, surrogate biomarker. In essentially a marker of the disease in a quantifiable way, whether we can see this. So people can use imaging. MRI is a biomarker to look at how much inflammation is there. And also you look at all the molecules that are expressed. They are also biomarkers, but often the term is used if you take some of the blood samples. Can the blood markers within the blood sample represent what is going on in the muscle? Because it's much easier to take blood sample and look for things rather than a muscle biopsy. So, and whether these markers, suppose for example in an untreated patient, marker X is 100-fold. After treatment, and the marker X goes down by 50%. That means you have a treatment responsive biomarker. So that is more quantifiable, because otherwise many times how do you feel is a very qualitative term. And how I feel and how Dr. Ryder feels are very different. So they are very difficult to quantify. But these markers, they are biochemical markers that are changing in response to disease. They're changing in response to treatment. So biomarkers means essentially a change that can be measured in a quantitative way.
And a question for any of our MDs, really, and I think this will probably need to be our final question for this session, but I do want to say for those of you who we did not have a chance to get to your questions, we'll put them in front of our panel and we'll post answers on our website or through Whova, so you'll have an opportunity to see what it is they have to say. So it's sort of a general question for any of you who want to jump in and answer this is, can you address my future relative to fertility and pregnancy? I assume that's for a JN patient.
We actually reviewed the available data in a paper that came out in JP's in April. In China, where there is a different genetic background, there is a slight increase in miscarriages. The data hasn't been done for the United States, but to my knowledge, I keep on getting emails from my kids showing me their kids, and that's the best I can tell you. I don't know, really, because now as we're discovering the different subsets of JDM, because of the myositis-specific antibodies, there may be some particular genetic component for the Chinese. Their disease is a little different than the United States. So I can't answer. That's one of the many questions. That's why we need more research.
So we actually did a study. Is it on now? Yeah. So we actually did look at it about 15, 20 years ago in our large population and looked at fertility and pregnancy outcomes. And the information we had, and this was back even before we were using as much aggressive therapy, really what it showed was that individuals could get pregnant. We found that the babies were sometimes smaller, so small for gestational age was a larger component than what you would have expected in an otherwise different population. Did not see the signal for miscarriages, but maybe wasn't a large group that we reviewed. It was about 15 individuals. So it wasn't a huge population. And I agree with Lauren that we do need more research.
What's that? It's 11:45. Do we have time for one more question? Okay. Now I have to find one. Okay, this is kind of a technical question, so I think I'll direct it to Dr. Nagaraju and Dr. Kinder. After T cells are synthesized and transferred to and mature, what if they are released into the body as immature T cells? Do you think these immature T cells could be the reason why they do not recognize the self-antigens in the cell membrane?
Okay. So, the question is, at the release of immature T cells into circulation is the reason for their so-called autoreactivity. So normally, most of our blood cells take T cells. They're all trained. They are told when they are born to discriminate me and not me, self and not self. So that means if we have 1 million T cells in our body, they all know not to react to my proteins. They're always able to react anything that enters into me. So, but in less than 0.1% of times, so you have T cells that leak out that has the capacity to recognize my own proteins as non-self. This happens very rarely. So that is reflected in the total incidence of autoimmune diseases where your T cells are recognizing your protein. It occurs only less than 1% of the population. That means 99.9% in a way, they almost always see only foreign agents, not the self. So where this education takes place, what we call thymic education. So in all of us, there is a gland called thymus. That is where when the cells are produced in bone marrow, they go into the thymus. There the screening takes place. If a T cell is likely to react to my own, that gets killed right there. It won't get released. The only ones in the thymus, that's what we call thymic education. That is where we tell these T cells, me or not me, show the flags of, if you see this, it's me. So that, if they react to that flag, the body kills them in the thymus. Thymus is a graveyard for all these cells that are likely to react to our own cells. But as I mentioned, nothing is foolproof. 99% is a great thing, right? How many things in life can be 99% sure? But sometimes this gets blurred because there are a lot of things that look like ourself and the immune system gets confused. So that's the thing that happens in a way. That's how our system is set up. But in autoimmune diseases, a small percentage of the cells, they come out. They are mature. It's not truly immature. Because they have the ability, only thing is they recognize our own tissues as foreign and start reacting.
Yes, Madam Chair, you can have any liberty you would like.
So I'm going to take advantage of this one more time here. So I have a question for our doctors, because as I'm sitting here and reflecting, I mean, incredibly proud of what the organization has accomplished, but when looking at all these studies, all these things that we have going on in different areas, these doctors are uber smart. You know, I sometimes call them smarty pants or other types of things, but just in their different specialties and everything, just to have them in the room and to have all these families in the room, that my question is, and because we're at, from a timing perspective, you got to keep it to like a sentence. If you had to leave us with a headline from your respective area of specialty in that, if you had to give us a headline of what more can we do to help you further Cure JM as an organization to our mission that Jim talked about and I talked about at the beginning. So really, what more can we do as a JM community to help further our mission, given your different respective roles? A headline. So I guess we're going to start down here. You're lucky, Ann. Lauren's already raised her hand, so you've got a little bit more time.
Great question.
Oh, you've got one. Okay.
What you are doing, early diagnosis. If you see something, say something. If you see a child at a railway station, ask them that you think is JDM. I can't tell you how much things have changed since I got on this bandwagon and how much Cure JM has helped with telling other families, gee, this looks like something and this is the place you go to. So if you could get children that you see and families to get to early diagnosis and early therapy, we know that the disease changes over time, but your work is really hugely important. Now for the science side, well, I think we've got much more than, I was the only person doing research for about 20 years in JDM. And it's wonderful to bring young people in and train these doctors, both for physicians and with scientific background. You need to see the patients to understand the variation, and you need to be a scientist to understand the mechanisms.
This is a tough question. I think I agree with Lauren that everything that you all have done has been wonderful and made a huge difference for all of us and for the patients, most importantly. So more of the same, I would say, is keep it up, and it's really growing strong. I think I agree with Lauren that, you know, in the end, we aren't going to be sitting up here forever, and we need the next generation to take our place, and we need to train them now, and the time is urgent, actually.
Now, I think I fully agree, you know, unlike MDs, they get to see the patients. People like me and Dr. Carr and Dr. Kinder, we work in the lab. This is an enormously motivating thing for us. We have a deeper purpose when we go back because we get to see all of you. So that impact, I think it is powerful. That is why these kind of gatherings are extremely critical. And then just to emphasize on what Dr. Ryder said, I always think that multiple brains are superior than a couple of brains. That means how can we bring multiple brains? That means the one way is to train young people like Travis and bring them. And the young is critical because they can take risk, they can challenge the norm, and then find something new. Because as we age, normally we are pretty protected. Our own experiences actually keeps us confined. But young people, the more young scientists, more young physicians we bring in and allow them to commit to this cause, that I think is going to transform the treatment for acute JM.
I thought this was supposed to be one sentence. But, okay, so participation in research. So I think Cure JM's families are a special group of families that are more generous in their time and their energy and their efforts in participating in research. And I think it's a lot that families are dealing with, just with their own personal lives, to extend their the time and energy getting an extra poke for blood draws and things like that. So that generosity in research that you are participating in is amazing. I think kind of spreading the word to others, especially new people who are diagnosed, to also participate in research. And also even talking to your physicians, if they're not bringing up things like CARA or mentioning that they're part of CARA, saying like, what's up with that? Like, because we want them to be part of the CARA network. I think a lot has been accomplished over the years with case series and all the amazing work that's been done at NIH and Dr. Pachman and Dr. Reed and others. But I think really to move us forward, we really need a big network of, North America and really the world to move us all forward. So participating in research. Sorry, more than one sentence.
I agree that this very multifactorial approach is definitely the most beneficial. Organizing people, educating patients and physicians, but specifically from my perspective as a young scientist entering the field of research, for me, funding is most important. I could work in any field. I could go anywhere. Whoever's going to give me, money for paying the rent and my reagents. So I think. Fundraising and funding research is going to be very important going forward, and is a lot of the clinicians keep agreeing upon is needing more research into what's actually going on. So I think that's very important.
So if it's one word, I'd probably say advocacy, and it's probably direct advocacy, but not in the sense of kind of preaching to the choir, to other scientists, to other so forth, but more like from a grassroots level to just the general community and at the government level. Because I think we live in very interesting and unique times. That at the same time, there's a lot more information, there's a lot more advancements in technology and knowledge and so forth. But at the same time, there's also a lot of, from the general people, a lot of skepticism as well. So the internet should be liberating, but at the same time, it can also end up being very, in some ways, restricting people, and that there's just this very dichotomous strain going on right now. So it's just families like yours who kind of see it are very much also in the front lines, and to also not, so somehow from the scientists and the medical professionals that message is somehow being lost, and that I think what we need is then the advocacy from engagement from the families themselves, really to change the attitudes and minds and understand that actually we live in very great times. There's opportunity for real advancement, and because of kind of some of those attitudes, that a lot of that isn't really being harnessed in the way that it can be to really effectively take us into the next generation.
Okay, I'm going to try to keep it in a headline. So advancing technology accelerates discoveries for a cure. I think that is my big message. And then my byline below it is we need to train the clinicians and scientists for the future. We're really, in trouble, I think, in medicine in terms of that pipeline.
One last thing, I think. So we can model how other rare disease foundations actually helped research. So I know Duchenne's muscular dystrophy, what they did 10 years back, they actually went to Congress and asked them to specifically fund research in Duchenne's muscular dystrophy at NIH level. Now, the National Institutes of Health has programs asking every year for research projects. So probably we can do the same thing, influence your lawmakers, let them actually tell NIH, we need more research. Can you allocate specifically some funds for JDM? So that way, it is going to benefit in the long term. I know you're all raising funds, but it's always better to involve government, partly because we pay taxes.
Well, thank you. Thank you.